Welcome back, pre-algebra. We're in lesson 7. We're going to talk first about multiplying decimal numbers. So let's just jump in to an example problem here, 7.1. And what you're seeing here is 4 and 12 hundredths times 63 and 2 tenths. So you're going to multiply these decimal numbers just like you would any other. There's a little step that you do at the end, but in the process of multiplying, we treat them like regular numbers. So I'm going to write 4.12 and 63.2, and I'm going to multiply them just like normal. So 2 times 2 is 4. 2 times 1 is 2. 2 times 4 is 8. All right, now I'm going to move over and I'm going to use this, what would normally be the tens place when we write out a long digit, and we're going to treat it exactly the same way. So to represent the fact that we're in the tens place, we're going to put a 0 here. That's going to help me put this in the right spot and to add it in the right order whenever I get through with my multiplication. 3 times 2 is 6, 3 times 1 is 3, and 3 times 4 is 12. All right, now I'm going to move over and I'm going to do the 6, and it is in the third position. So I'm going to fill this in with zeros to remind me to write my answer here in the third column. 6 times 2 is 12. Carry a 1. 6 times 1 is 6, plus that 1 we carried is 7. And 6 times 4 is 24. So I'm going to write my 4 and my 2. And now I'm going to treat this just like a regular multiplication problem. I'm going to add straight down. That's 4. That's 8. That's 13. Carry the 1. That's 10, carry the 1, that's 6, and that is 2. Here is what you do at the end of multiplication when you are multiplying decimal numbers. You go back and you count the number of decimal places. So we have 1, 2, and 3 decimal places in these two numbers combined, right? So we have 2 decimal places here and 1 decimal place here. We add them together. 2 and 1 is 3. So I have 3 decimal places. So what I'm going to do is I'm going to start here and I'm going to move, we're going to pretend there's a decimal, and I'm going to move that decimal place 3 times. 1, 2, 3. And put my decimal there. And that is the answer and the final step whenever you are multiplying decimal numbers. You count the number of decimal places and then you move that into the bottom. All right, you count that into the bottom, and that's where you put your decimal, and that is the answer. And I'm going to show you that is the answer. I'm going to pull my calculator up and show you how you can check that answer. 4.12. At this point, I only want you to use your calculator to check your work, okay? 4.12 times 63.2, 260.384. We know that's correct, right? That is the only thing you want to use the calculator for at this point, is to check your work periodically and make sure you're doing it. And especially if you can't seem to get the right answer, then you can pull out the calculator to help you along. But do as much of it as you can yourself on the front end, because then when you get to Algebra 2, all of this will be easy, right? If you depend on the calculator now, then when you get to Algebra 1, Algebra 2, it's going to be more difficult because you didn't do the brain work that you needed to do. And I want you to have success. So do the brain work that you need to do now. So let's do another one of these. Let's do 7.2. Let me clear the page. 7.2. We have 6 and 78 hundredths times 0 and 537 ten-thousandths. So yeah, tens, hundreds, thousands, 10,000ths. All right, so again, we do the same process. So we do 6, 7, 8, and then we do, this is a 7, 3, 5. We put our decimal in for 6.78. 0, and then we put the decimal in and the 0 in here. And we can skip this part when we get to the end, but we at least need to go here to the 0. And I'll show you why. So let us do the math. 7 times 8 is going to be 56. Carry the 5. 49, that's 54. Carry the 5. Once I use it, I like to cross it out. So that's 42. This would be 7. And we'll put our 4 here, 47. All right, and I used that 5, so I'm going to cross it out. 3 times 8 is 24. Now, I forgot to do what I was supposed to do, right? You got to put your 0 in so you know that you're starting in the right place. 24, so it's 4, carry the 2. 3 times 7 is 21, plus 2 is 23, carry the 2. 3 times 6 is 18, 19, 20, so that's 20. Okay. Next line, so I put in 2 zeros. 5 times 8 is 40, 0. Carry the 4. 5 times 7 is 35, plus 4 is 39, so it's 9. Carry the 3. 5 times 6 is 30, plus 3 is 33. Now, we don't have to do the zeros. We don't have to do those because we know we're just going to have a 0 in the front, right? So we can stop right here. Add everything together. And now we're going to count the decimal places. 1, 2, 1, 2, 3, 4. 6 decimals. So 1, 2, 3, 4, 5, 6. 0 and let's see, tenths, hundreds, thousands, 10,000s, 100,000s, millions. So that would be 364,086 millionths is how you would say that is your answer. All right, that is how we would do that multiplication. So now let's talk about division of decimals. So I'm going to clear the page. And division of decimals is very similar in that we adjust for the decimal. But the difference in multiplication and division is that when we divide, we adjust for the decimal first before we do the math. With multiplication, we adjust for the decimal after we do the math. With division, we adjust for the decimal before we do the math. So let's do a problem, 7.3, and I'll show you what that means. We have 0.084 divided by 0.35. So that is 84 thousandths divided by 35 hundredths. So let's set it up. We have 0.084 divided by 0.35. So we adjust first by moving the decimal place whatever places the divisor tells us to move it. So we put our dividend here. The dividend is the number that's being divided. The divisor is the number that's doing the dividing. That's the number of groups we have to have. So the divisor here, we have 1, 2 decimal places. So we're going to move in the dividend 1, 2 decimal places, and we're going to move that decimal up here to the top. Now, if you have zeros in front of these numbers, you can ignore them. You can erase them. All of that can go away, right? We don't worry about that once we move the decimal. Now, we're dealing with a whole number into this number. So what I'm going to do is I'm going to say 35 goes into 8 0 times, right? 0 times 35 is 0. So that's going to be 8. And now we bring down the 4. Right? We ignore the decimal. Once we adjust it, we ignore and put it up in our answer, our quotient place. We can ignore it from that point on because it's already in the answer because we adjusted for it first. So now I can say 35 into 84. That goes 2 times because 2 times 35 is 70. So 2 times 35 is 70. Let's see what we have left. I have a 4 here and I have a 1 here. So I have 14 left. But I ran out of numbers. So what do? Here's what we do. We add a 0 because you can always put more zeros behind a decimal, and it does not affect the value of the decimal, right? The zeros could go on into infinity, and it still is only 4/10. It does not affect or impact the value of this number to put zeros on the end. So we're going to put a 0 here, and then we're going to bring it down. And we're going to say 35 into 140. Well, if 2 times 35 is 70, then I know 70 is 140 is 2 times 70, so 2 times 2 would be 4. So 4 times 35 would be 140, right? And we'll do it over here just to make sure. 4 times 5 is 20, carry the 2. 4 times 3 is 12, plus 2, that's 14, so 140. So 4 times 35 is 140, and then I have no remainder left. So my answer already has the decimal in it, and that equals 0.24. All right, or 24 hundredths. That is how we would do or deal with a decimal in a division problem. In division, you adjust for the decimal first, and then you just do the math afterwards like normal. The only difference is you can add zeros. Once you're past the decimal, you can add as many zeros as you need to finish the problem. All right, so let's do one more, and let's do 7.5. Or 7.4, sorry. So we're going to start with 21. So we have a whole number divided by a decimal 5/10. 21 divided by 5/10. So we put 21 here, and we put our 5/10 here. And notice I didn't even write the 0 because I don't want to worry with it. Now, this is a whole number. There's not a decimal. Well, technically, we know there is. We know there's a decimal right here behind the ones place. So when we have our divisor with a decimal and we move it back 1 to here, we do the same thing here. We just stick a 0 in that place. So now we put the 0 or the decimal right up there in the top in the answer. So now we can erase this right here and just do the division. So 5 goes into 2 0 times. We can't do it. But 5 goes into 21 4 times, right? Because 4 times 5 is 20. We subtract and we get 1. We bring down the 0. 5 goes into 10 2 times. 2 times 5 is 10. Subtract, and we have no remainder. So 21 divided by 0.5 or 5/10 is going to be 42. All right. So you see how fun that is? The answer is there for you. Once you're done, you don't have to count decimal places because you did that on the front end. Let's do another one. Let's do 7.5. So we have 31 divided by 8. So a whole number divided by a whole number. So how is that dealing with decimals? Let's look and see. So we've got 31 and we have got 8. Well, I already know, because I know my multiplication tables, that 31 is not in the multiplication tables for 8. I already know that. I know that 8 times 4 is 32, and I know that 8 times 3 is 24. And this is not 24, and this is not 32. So my answer is going to be a decimal answer. So what I need to do is I need to go ahead and put my decimal right here behind the ones place, and I'm going to go ahead and put in a 0 to start with, because I know it's going to take at least 1, maybe more, to solve this problem. So let's go ahead and do the math. 8, notice I didn't have to move any places because there were no decimals here. I just put in the decimal that was already there and moved it up into the quotient. 8 into 31, we know that's going to be 3 times. 3 times 8 is 24, right? Subtract that, and we get 7. Well, 8 doesn't go into 7, does it? No. But we can bring down the 0, and we can say 8 goes into 70. It does. And it goes into 70. That would be 7 times. Is that right? 8 times 7. I know 8 times 8 is 64. Yeah, so it'd be 8 times. So 8 times 8 is 64. So 8 times 8 is 64. See, even the teacher has to think about our multiplication table sometimes. So then I subtract. Notice I wrote it over the 0 right behind the decimal. And I subtract and I get 70 minus 64. That's going to be 6. Remainder. Well, I need another 0 because I still have a remainder. So I'm going to put another 0 and then I'm going to bring it down. 8 goes into 60. Well, if 8 times 8 is 64, then 7 times 8 is 56, so that's the number I need to use. So 7 times 8 is 56. I subtract that, and I get a 4. I still have a remainder, so I need another 0. So 0 is going to extend this, and I'm going to bring that 0 down. That makes that 40. Well, 40 is a multiple of 8. 5 times 8 is 40. And that gives me no remainder. So my answer to 31 divided by 8 is 3 and 875 thousandths. I had to think for a second. It's the thousandths place. And that is how you would do division when you have whole numbers, but they're not multiples of the divisor. The dividend is not a multiple of the divisor. You would divide like that by go ahead and putting the decimal place behind the ones place and putting it in the quotient, and then just adding the number of zeros you need until you finish with no remainder. Okay? Let's do one more, and let's see what we can do with this. We've got a really, really long problem, 7.6, or I should say long decimals. I have, oh my goodness, how many zeros? Oh, okay, just 2. This is tenths, hundreds, thousands, 10,000, 100,000, millions. So millions. 4,415 millionths divided by 32 thousandths. Okay, because this is tens, hundreds, thousands. All right, so I'm going to set this up. First of all, I'm going to drop the first 0. It's not needed. And I'm going to put this in. I'm going to drop the first 0. It's not needed either. And it's okay to do that because 0 times 0 is 0, and it does not affect your answer. So now I'm going to count my decimal places. 1, 2, 3. 1, 2, 3. And if you want, once you do this, once you figure out what you need to do, you can rewrite the problem, right? Because I'm on the computer and I can do it, I'm just going to erase. You can erase too if you want. And then I'm just going to erase these zeros in the front. I'm actually going to just do this right here. I'm going to erase all of this and bring this over because I can, because I'm on the computer. All right, but now this is set up with the decimal in the right spot and a whole number to divide by, which is what we want. And I'm going to treat this like these two are a whole number. I ignore the decimal as I do my division. So 44 divided by 32, I can get one group of 32 out of 44. 1 times 32 is 32. I'm going to subtract, and that gives me 12. I have 12 left. All right, I can't get a set of 32 out of 12, so I'm going to bring down the 1. And I am going to do the math and realize that I can get 3 sets of 32 out of 121. So 3 times 2 is 6. 3 times 3 is 9. And I'm going to subtract, see what I have left. And I have a 511 minus 6 is 5. And 11 minus 9 is 2, because I had to borrow. So that gives me 25. I can't get a set of 32 out of 25, so I'm going to bring down the next number. And, well, I would have to bring down the next number anyway, right? So I believe I can get 7 sets of 32 out of that number. So let's see if that's right. 7 times 2 is 14. That's 4. Carry the 1. So carrying the 1. 7 times 3 is 21. Plus 1 is 22. So 22. So I subtract. And 5 minus 4 is 1. And 5 minus 2 is 3. All right, so something that I forgot to say is that we want to round the answer to 2 decimal places. I forgot to give you those instructions. Round it to 2 decimals. So once we get to a point where we have 3 decimal places, I can round, because I just need to round it to 2. So you just need to get to that second decimal place, and then get the next number. You don't have to finish it. You just need to see whether or not you can round with this next number. So if my answer is 0.1, oh goodness, it just kind of went all over the place, didn't it? My pen just jumped. If my answer is 0.137 and I'm rounding to here, I'm looking at this number to see if it is 5 or more, and the answer is yes. So I would round this to a 1. I would add 1 here, right? So the answer would be 0.14. Because I rounded my answer to 2 decimals. So even though I didn't take it all the way out to the end and add 0, 0, 0 until I had no remainder, I didn't need to, because my instructions said to round to 2 decimal places. So you just go as far as you need to go to get where you need to get to the, and if you're rounding to 2 decimal places, then you just need to solve to 3 decimal places so you can round to the one that you need to round to. If you only had to round to 1 decimal place, you would just solve to 2 decimal places so that you could see if you could round or not. And here is the deal. If this had been less than 5, then the answer would have been 0.13. So we just needed to figure out what this was in order to determine what this would be, because of this requirement in our answer. And here is the deal. When you type in your response, your answer in the system, if the directions tell you to round to however many decimal places, and you do not round to those decimal places, you do not get credit for being close or for finding the right answer. The whole point is to follow the directions. So if you do not round, it will be marked wrong. Do you understand? So when it says round to 2 decimals, round to 2 decimals, or it is incorrect. I'm telling you that now so that you won't get it wrong later, because I want you to have your best grade. All right, let's clear the page and talk about estimation. All right, estimation is a technique that is used to check whether an answer is reasonable. Estimation can be done with both whole numbers and with decimals, and the idea is to round the number so that the arithmetic can be done mentally. For both whole numbers and decimals, this involves rounding the first non-zero digit. When working with decimals, estimation helps us quickly check that we have placed the decimal point correctly. For example, in subtraction problem, let's say 912.0039 minus 8.93, we can round this number to 900, and then we can round this number to 9. So our answer should be somewhere in the neighborhood of 891 when we do this math, right? Give or take, because we rounded by 12. If we rounded to 100ths place. But that doesn't make sense. What we want to do instead when we round or estimate is we want to try to round both to the same decimal point or the same place. So we want to say this is about 912 and this is about 9. That answer would be 903. So that's just an example of knowing where to round to so that the decimal point's in the right spot and so the answer is closer to what we can expect, the actual calculation. So in this case, the actual calculation here, I'm going to do it on the calculator just for the sake of speed. For this, you don't want to sit here and see me do all of this math. 912 8.93 is equal to 903.07 something. 0739. So 0739. That's the answer. It's pretty close, right? So that is what you want to do when you have. All right, so let's try a practice problem. So we're going to estimate when multiplying decimals, estimation helps us to check that we have placed the decimal point correctly. So when we say 4.12 times 63.2, that is about 4 times 60 because it's the same decimal position, right? So 4 times 60 is going to give us approximately 240. And that means approximately equal to 240, right? It also means congruent, but we're going to use it for approximately. Actually, we want to use the right symbol. It's approximately equal to. We have two approximation signs on top of each other. So approximately 240, but when we do the actual math, we find that 4.12 times 63.2 is equal to 260.384. So how far off was that? We still know we have the right spot here. We knew we had the right decimal place because we chose to leave the decimals in their current positions. So if I were to estimate through this calculation here, 6.78 times 0.0537, I would say that would be approximately 7 times approximately 0.05. So that would be approximately 0.35. Now when I do the math and I check my work and I find the actual answer, 6.78 times 0.0537, I find that the answer is 0.36. So approximately 0.35 is very close to 0.36, which if we rounded to two decimal places, we would leave at 0.36 because 4 does not round this up. All right, so you can see how estimation can help you when you want to quickly figure out a number. Now, I will say this, as far as what I teach and the way that I teach it, I don't place a lot of emphasis on estimation. Estimation has its place, but not as much in the decimal realm. If you are going into some of the higher sciences, like chemistry, physics, you might need that there. But for the main part, we don't really do a whole lot of decimal estimation. And if we do, we want to get it tight, bring it down to a couple of places and not have this big long number. So I'm not going to give you just tons of estimation problems, is what I'm trying to say, because I don't feel like at this point in pre-algebra it is super necessary. You just need to understand what it is and how it could be useful. Okay, so that is all I have for lesson 7. I will see you in lesson 8.